All right, here we go for part two of solving systems algebraically. Part two is going to be what we refer to as the elimination or combination method. You'll hear it called both. And that's because you use both the concepts of combining to eliminate. This model for solving systems is really useful when it's hard to get one of the variables alone. So if you remember substitution, it said get one of the variables alone in one of the equations. Sometimes that can be incredibly messy and create fractions. And that's where this method comes into play. One of the nice things about having two options is that some of you will prefer one versus the other. And you now have two different tools in your toolbox to use. And you can use whichever one you prefer. So let's go ahead and get through this. This video will probably be a little bit shorter as we go through and look at this one. So let's share screen here. And let's take a look at the notes for using elimination or combination method. So in order to solve a system using elimination or combination, the first thing you want to do is you have to make sure all of the terms are lined up. Now, typically standard form is the best way to do this. And if you remember when we did linear equations in second quarter, we said that standard form, which was the nice and neat and tidy one, basically only had two purposes. One was to find x and y intercepts, and the other one was for solving systems. And at the time, we didn't know what that was, but now we do. So standard form is great for using elimination combination method. You need one of the variables to be the same number but opposite sign. Now, in an ideal world, this will be done for you already. Sometimes it won't be, and you're going to have to manipulate your equations to make that happen. And our final example will have us do that. You're going to combine the two equations to eliminate that variable. All right, and so there's your words, combine to eliminate. So whichever variable had the same number opposite sign, we're going to eliminate it by combining equations. You're going to solve for whatever's left, and then you're going to repeat steps 2 and 4 to solve for the other variable, or substitute that value into either equation. And I'll show you both options, and then you can decide how you want to finish it. So again, line them all up. You need one of them to be the opposite sign, combine the two equations to eliminate, solve, and then repeat those steps. So if you need to pause to get the notes here, go ahead and pause. I'm going to go ahead and look at the first example for you to show you exactly what it is that we're doing. All right. So here we go. We have our two equations here, and you'll notice that none of the variables are set up nicely to get alone. And that's why our elimination method is key. You'll also notice I already put them in standard form for you. Typically, you're going to use this method when they are in standard form. The y values are already prepared to eliminate. One is a positive 3y, the other is a negative 3y. This is what we are looking for. This is what we want to see. We want to make sure that we can cancel them out. So what we're going to do is we are going to combine these two equations, and we're going to combine straight down. So I'm going to take negative 5x and positive 2x, and I'm going to combine those. And when I combine those, I get negative 3x. I'm going to combine the positive 3y and the negative 3y, and those cancel out. The equals come straight down, and now I'm just going to combine these numbers of 19 minus 13, and I'm going to get 6. You'll notice as I combine these why it is so important that everything lines up, because it's the only way you can do this. Solve for x. X equals negative 2. I now have the first part of the solution for my system. I combined the two equations to eliminate one of the variables. Now what I'm going to do is I'm going to use, for the final step, the part that I wrote in by hand. I'm going to take this negative 2 for x, and I am going to now substitute that value back into either equation so I can find y. Now I'm just going to put it in right here for this x. So this negative 2 right here, I'm going to substitute right back in there. So that becomes 2 times -2 minus 3y equals -13. This is -4 minus 3y equals -13. Add the 4. Divide. And y equals a +3. So we combined the two equations to eliminate y. We found out what x was, and then I took that x value and I plugged it back in to find out what the y value was. So that's solving a system using that combination elimination method. Okay, so let's do another example. So my second example, the letter x is now prepared to cancel out. Everything is lined up perfect, so we can go ahead and combine. So I'm going to combine straight down, and the 8x and the -8x, they cancel out. -5y and +6y simply makes y. Well, that was nice. And then -11 and 2 makes -9. Well, lo and behold, this one, when I combined, eliminated everything and had the solution for y already sitting there for us. So I know the y value is now -9. Let's take that value right there and let's plug it in for that equation for the letter y. And I could plug it into either equation, but that one's just sitting there for us. So that becomes -8x plus 6 times -9 equals 2. So -8x minus 54 equals 2. Add the 54. -8x equals 56. So x equals -7. And there's the solution to your system. If I wanted to use substitution, I could, but getting one of those variables alone is going to introduce fractions, and then you have to deal with fractions the entire way. So if the equations are lined up and you're ready to eliminate a variable, it's really straightforward and easy to now solve that system. Our final example, however, is going to show what happens if it is not prepped to eliminate. And this is where it's going to take a little bit more work. So I'm going to start off with those two equations, and we recognize that none of the x's or y's are ready to eliminate. So what we have to do is we have to find a number where they'll meet. So where would 2x and 6x meet? Or where would the 5y and the 10y meet? How could I change those equations to make that happen? So let's start off with the x's. Let's eliminate the x's. Well, I have a 2x and a 6x. If I could get this 2x to get larger and become -6x, I would be able to then work with those equations. All right, so I am going to take this first equation, and I'm going to multiply it by -3. If I took the entire equation and multiplied it by -3, that would turn 2x into -6x. So 2x times -3 is -6x. 5 times -3 is -15y. And 13 times -3 is -39. And then this one, I'm not going to do anything with it. I'm just going to leave it alone because then the x's will cancel out. So let's just bring this over here. So this is +6x plus 10y equals 14. Let's combine and eliminate. So the x's will now cancel out. -15y and +10y is -5y. -39 and +14 is going to make -25, which means y equals 5. Now I've got one of two choices here. My first two examples, I would just take this 5 and I would have plugged it into either equation and I would solve. But I want to show you that step 5 and how it can be done in a problem like this. I set up the x's to eliminate and cancel. So what I want to do for this second step, or this second half of the problem, is let's eliminate the y's. What could I do to this first equation so that the y's would eliminate? I would multiply this top equation now by -2, because if I multiply by -2, the y's could now eliminate. So I'm going to rewrite the problems down here. Now, you absolutely don't have to do this, but I'm going to just so we can see it visually. I am now going to take this top equation, and instead of multiplying it by -3, because that would cancel out the x's, I'm going to multiply it by -2, because that'll cancel out the y's. So 2x times -2 is -4x. 5 times -2 is -10y. 13 times -2 is -26. And now let's bring these down. This is 6x plus 10y equals 14. Let's combine. Now the y's canceled out. -4x and 6x becomes 2x equals -12. Divide the 2, and x equals -6. And there is the other half of my answer. Sometimes you will have to multiply both equations in order for the variables to cancel out. So maybe you have a 3 and a 2. Well, they meet at 6, so you're going to have to then change both equations. So sometimes you're going to have to multiply just one. Sometimes you'll have to multiply both. And we'll talk about that in class. So that is solving systems using elimination method. Again, line them up, set it up so that you can cancel out the variables and then solve for the other one. We're going to have an IXL section on this, and then at the end of the week, we're going to go ahead and mix them all up, and then you're going to have to pick and choose what methods you want. Again, if you've got questions, come see me tomorrow, and we'll walk through them if we need to. Have a great day, guys.